So the 4 key metrics came from the DevOps movement. Everybody's heard of DevOps, but just for the avoidance of doubt, because DevOps these days means a lot of things to a lot of people, it means the wrong thing to some people, I would argue. But what I mean DevOps is like the movement, the feeling, the community, the way of looking at the world, which came from the DevOps movement. Basically, operations engineers got jealous of all the tools that we developers use. Apologies to all the operations people in the room. They got jealous of our tools, but they were also frustrated with the stuff that we kept throwing over the fence at them. So they started trying to figure out a better way of looking at things, a better way of working, so that they could optimize ways of delivering software, ways of running software, ways of evolving software. Developers then figured out that this was actually quite cool and these people were onto something, so then we kind of started doing DevOps too. And so DevOps evolved lots of practices, so things like CI/CD, things like breaking down silos between teams, things like blameless postmortems, they're all the practices that came out of the DevOps movement. But the big thing about DevOps is learning and sharing and delivering software incrementally and over and over. And there was lots of these practices. Everyone was doing them, and they seemed to be having a positive impact, but nobody was sure that they were having an impact. And that's when Dr. Nicole Fosgren and Jez Humble and Gene Kim came along. So they thought, we can do some maths, especially Dr. Fosgren, so she's like a statistician. We can do some maths to prove, or maybe disprove, whether or not all of these things that we're doing have a positive impact. So she crunched a lot of numbers. If you read the book, you don't have to read the book Accelerate, but there's like a whole third of the book is all about crunching the numbers. Super statistical. And basically what she and her co-authors proved was there is a greater than correlational link between doing all of these things, these practices, which Thoughtworks talk about all the time, but other people do too. If you do these things, you'll have a positive impact. What positive impact? This. You'll have at least a 2x improvement on all of these things. And 2x improvement on things that non-technical people care about, right? Commercial goals, profitability, market share, productivity, so things like the CEO cares about. But also non-commercial goals, the things like that we maybe care about. So the quality of the services, so the quality of the software that we're writing, customer satisfaction, we obviously all want to write software that customers love, but even as well, employee satisfaction. They positively proved that by adopting lots of these DevOps practices, employee satisfaction went up. That's good, that's us, right? We're the employees, we're the people writing this code. So we're not just doing this because Thoughtworks said it was a good idea or because Gene Kim said it was a good idea. It makes our lives better. So what are these practices? So this is a picture from the book, Accelerate. So here's the things on the right-hand side, which is, again, the organizational non-commercial performance. Each of these arrows is where they've statistically proven a strong link between doing the things at this end of the arrow and the resulting things here. So if you want to get good organizational performance, you need to have people who are satisfied in their jobs and are delivering software efficiently and have a healthy culture. Software delivery performance also improves non-commercial things, like if it's easy to ship your code, then people will feel better, right? How do I improve software delivery performance? I do things like lean product development, I do things like lean management, or I do all the things that Thoughtworkers talk about all the time. So like this is why Accelerate was great, because someone statistically proved all of the stuff we keep telling people to do, it statistically proves that it was worthwhile. And before that, they recently figured out that transformational leadership was important as well, so people high up in the exec, giving people the permission to build and learn, all this kind of stuff. So this is good. So you want to do these things, but how do you know that you're having an impact by doing these things? And that's where the 4 key metrics come in. They figured out that there are 4 numbers, which if you capture the data and calculate those numbers, if you're improving those 4 numbers, the 4 key metrics, then you will be getting towards this. You'll be improving this and you'll be improving this. And by doing these things is how you get those improved. So what are the 4 key metrics? They are deployment frequency, lead time for changes, change failure rate, and time to restore service. Thoughtworks have had them on the Tech Radar. Probably people will mention the Tech Radar over and over again. Tech Radar has had them in Adopt since 2021, but we've been watching them for a long time before then because they've been super helpful. And they're kind of things which we've been optimizing for anyway, but now we have specific definitions. Deployment frequency, we mean deployment of software to an environment which is potentially usable by customers. So it doesn't mean released, it can be behind a release toggle, but it means it's available to be turned on. Lead time for changes, we don't mean lean cycle time. That's lean cycle time, which is like this from the point a story gets created and put in a backlog. Lead time for changes isn't that. Lead time for changes starts when the developer thinks they've finished. Right? So if you've done pair programming and you've done some localized testing, then that's fine. But it's the point from when you think you're done to the point that gets into prod. And time to restore service and change failure rate. It's not super well defined, but it basically means when something in your service means that people can't use your service. So it could be something's broken, or it could be something's going so slow that I've stopped using it because I don't care, because I'm pissed off. So it's that kind of thing. So how do we calculate them? Or how do we get to them? So what you want to do is this. I didn't really understand this, but then I worked with somebody in the audience and their company. I'm allowed to say, actually, OpenGI, because the client let us talk about it. We worked with OpenGI. So we set up the 4 key metrics up to here. We then realized that by showing everybody the 4 key metrics and making them public to the teams that were doing the work, they could like go, oh, this is cool. Maybe we want to improve our deployment frequency. So that's the thing. So what we really want to do is get to this bit at the end of the talk, if I don't talk too long. We want to get to like self-service and teams, actual people writing the software, sitting there, seeing the lead time and going, okay, that's like 2 days. How can I make it 1.5 days? All this kind of stuff. So that's what we're going to get to. But to get to there, you need to do some stuff. So step 1, define and locate. And this is the only step which doesn't have a specific output. It's just work you need to do to get to the next steps. And this is where we need to explain something. So sometimes this is obvious to people and sometimes it's not. There is a mental model that underpins Accelerate, which is super important. If you don't have this mental model, the 4 key metrics kind of don't make sense. So the key thing is getting this mental model. The simple version of this mental model is the picture here. So right, there's a pipe and the pipeline starts when you commit a change to source control, and the pipeline finishes when your thing is deployed to production. That's that simple. The reason people don't get it is because that is like nobody's environment looks like this. Right? Nobody's is this simple. So lots of people, OpenGIs look like this. And actually, if you're doing microservices, this is what you should have. So if you're doing microservices, you should have a separate repo per service. You should have an independent pipeline per service so that if I've changed my service, I can deploy without waiting for everyone else. Boom, gets to the end. One end-to-end pipeline, which is cool, right? So we were using Azure DevOps, which is an X on Microsystems employee I never thought I would say is good, but it was awesome, worked really well. This is the thing. Lots of people aren't lucky enough to have this. So you might have this. If you're doing Jenkins, where it's really easy to create little short jobs, or like a pipeline which feeds into a pipeline, which feeds into a pipeline, you probably have this. So your first job listens to a source control repo, someone does a commit or a push, it goes, oh, it's cool, I'll pick it, I'll compile the code, I'll run some linting and stuff, I'll run some some unit tests, and then I'll put the resulting jar, if I'm doing Java, into an Artifactory, and then a human being, or maybe something smart, then triggers the second one, which pulls it down from Artifactory, deploys it to a staging environment, does maybe tells a QA to go and do some QA testing, blah, blah, blah. They say they're fine. Then finally, when everyone QA says they're happy, then they press another button and another pipeline starts up and it gets deployed. So this is what lots of people have. But because of microservices, lots of people have this, which is cool, right? It's not. This isn't good or bad. It's just what everybody has. If you've got this, capturing your data for your 4 key metrics is a bit hard, but it's not impossible. The thing that I'm going to show you in a minute is the one that lots of people have for legacy reasons, and there's a reason I'll show you the picture, because you need to have a little bit of a think to find things. This is what lots of people still have, because for various reasons, you've gone to microservices or you've gone to independent components, but because of legacy reasons, right? Maybe you're just early on your DevOps journey. Things are released into prod in a more controlled way. So therefore, you bunch them all together, you pile them all up, you do a big test of everything all together, and then you do one big deployment, which is cool. Like it's not brilliant, but it's what happens, right? People have this. I see this all the time. And I'll explain in a minute why it's complicated, because whatever your pattern is, you want to find some key data points on these pictures to be able to get your inputs into the things you'll use to calculate your 4 key metrics. So, what are those things? You will need to know the timestamp of when a change set was committed, number 1, right? So if your pipeline looks like this, you're like, this is dead easy, right? Because it's this thing probably it's when the build starts. That's a good proxy. You also need the timestamp of when that change set was deployed. But if you've got one of these, then this is why it gets complicated. Because deployment 264 will probably include 2 changes from repo A, because that team's going super fast, right? They're like shipping stuff all the time. So their component, they're releasing updated versions of their component to Artifactory really frequently. There's 1 change from repo B. That team are doing less. You know, they've maybe got harder stuff to do, or they're releasing less frequently, or like they're pushing things less frequently. Repo C may or may not have some extra stuff. To be able to calculate your 4 key metrics, you'll need to break open deployment 264 to find out which change sets came from repo A and repo B and repo C, which isn't impossible, but it's hard. So you end up writing bash scripts which pull apart Git logs or something, right? Which is cool. The other thing is, if you're doing the earlier, easier version, your build tool will probably remember, because it will be your start time will be the pipeline beginning and the stop time will be the pipeline ending. So you just take some timestamps of a pipeline run, which Jenkins or whatever just has. If you've got this, you probably need to pull them out, stick them somewhere, maybe like a local database or a spreadsheet, and then break them up and then pull the pieces apart. This is why ADO is brilliant, because ADO has all of this stuff. It makes you do end-to-end pipelines really easily, etc. Sorry, ADO is Azure DevOps. So we've got those 2. So however you get them, you've got your start time and your end time. You also need to know about change failures. So if you read the book, Accelerate, which goes into great detail about how to find your change failures, it's not really very clear about what a change failure is. So I advocate cheating. So our definition of change failure was, if something's broken, it's obviously a change failure. But if someone tells you that something's broken or they can't use the thing, then it's broken as well. And what you do is you create a ticket. So it's really easy. You just go in and create a new ticket in Jira, ticket type in Jira called change failure. And when something blows up, you create the ticket. So that gives you the start time. And when you fix the ticket, that gives you the end time. Key point number 15, a restoration, so mean time to restore is restoration of service. So say, for example, not that this would ever happen, but if I wrote some code which memory leaked, so I deploy it, like my chain set comes in, right? And it's cool, but it memory leaks. So occasionally it fails a service. We notice that that's a failure because the service has failed. We can restore my failure by rebooting my service. So then we fixed the problem. Sorry, we've resolved the issue, but we haven't fixed the problem. So hopefully we've created a ticket which someone goes in and fixes my memory leak. But you stop the clock when someone has restarted the service, because technically your service is back up available again, right? So could you care about, and so the 2 things are related, but they're separate, they're independent, they're orthogonal. So that's all the pieces. So if you get all these pieces, and this is why if you have a ticket, it's quite good. Other key things to point out, we had, my last client, we had a pretty smart set of observability. It wasn't perfect, but we had some nice observability. So we had some really nice New Relic scripts which were running and checking out things. We had a downstream third-party payment gateway which kept falling over. So they would trigger alerts because their system was down because they couldn't take payments. So we were creating tickets. We were only deploying like 3 times a day, but we were failing like 17 times a day. So you can, we were like, this can't be true. How can our change failure rate? Our change failure rate was greater than 100% because we weren't correlating. It wasn't like all of these changes were creating failures, but we don't really care. I'll talk about that in a minute. What you care about is how many failures and how many change sets you've done. So you can have a change failure rate greater than 100%, but then you fix your environment. So that's part 1. So now we move to step 2. So we found wherever they are in our environments, we found what our 4 key metric data sources are. They're not our metrics, they're where we're going to get the data from to calculate the metrics. And so the things you need are commits, deploys, and failures, as you can see on the left-hand side. What we're now going to do, because what we really want to do is quickly get this data in front of us as soon as possible, and typically this is me and someone at the client. So at this point I need to name check Pete. So Pete Hunter, it was me and Pete, and we did this at OpenGI. We were making a handcrafted minimal viable dashboard, which meant we would gather the data, stick it in a spreadsheet, calculate it, and then type the numbers once a week into a wiki page. I think it was once a month actually, because it was painful, but it was good. So then people could see the numbers, right? So Excel is your friend. It doesn't need to be Excel, can be Google Sheets, but like you don't need to wait until it's beautiful. I'm going to show you a beautiful thing at the end, which we are super proud of, and you'll see screenshots of. Pete and I, it's the only code we've written for the last 10 years, maybe 5 years. But we had, like, part one was like a dodgy hand-typed thing. So Excel is good. So, but when we did this, we realized that this is also not in the book. They go, here's your deployment frequency. There are some things that you don't realize when you're trying to calculate deployment frequency, which I'm now going to tell you about. So, number one, it's easy to capture. It's just the number of times something gets deployed, not released, but deployed to your, ideally, prod. When Pete and I were working at the time, there was a big in the future marketing release of the product, so we weren't live. So we counted prod as the highest environment. So it wasn't prod, it was like pre-prod. But the idea being it was the environment where when marketing said we will release this product, we wouldn't say, oh, we've got 3 more stories to do to make this work. We thought we'd release production-ready code. So it's easy to capture, but it's not simply a count, it's frequency. So it's like the number of times you're doing it per day, right? So and what you need is the average number of deployments per day. Again, accelerate, and all the DORA reports don't say over what period. Because if I do the average number of deployments per day over a 1-day period, that's going to go up and down all the time. So we figured out eventually, and this has worked now for 3 clients, 31 days is a nice window. Because it means you'll take account of weekends, you'll take account of like things, people doing crunch time when they do more stuff. So it'll give you a nice kind of indication of what your actual deployment frequency is. So a number of us the last 31 days. There was a few things we learned as well, because it was like going back to statistics school. Number one, you can't average an average. We were calculating the average per day, and then we averaged that over 31 days. That's bad maths, which I feel guilty with, because I did 4 years of statistics at university. And all our numbers, we thought they were awesome, but they were wrong, because we were averaging an average. So don't average averages. Take the number of deployments over a 31-day period and then average them. Don't take the average from day 1 plus the average from day 2 plus the average from day 3, because that's bad math. And number 2, this killed us as well. We forgot this. We had a spreadsheet, so every time there was like, if there were 7 deployments in a day, we would manually type in the date and 7, right? And then there was another day when there were some deployments, we would type in the date 6. We forgot to add days when there were 0 deployments, so weekends. So we had like 25-day months, which again, we were like, so our number was higher, our deployment frequency was higher, because we weren't counting days with 0. So these things sound obvious, but if you haven't written code for a long time, you have to find this out by accident. So yeah, don't forget 0 deploy days. So whatever you're doing for your data, make sure that you're somehow putting in 0 if there's a day with no deploys. Next one is lead time for changes. This one requires 2 data points. This is the deployment time for the change set minus the kind of commit or push or whatever time. This is easiest if you're doing trunk-based delivery. This is not easy if you're doing branches and merging and pull requests. If you want to have a really long debate with developers, ask them when they think you should start the clock. Because it's quite easy to take when the pull request was merged as the start point, and then the end point is when it's deployed. That is cheating, because if that pull request stayed open for 2 weeks, technically it's been dev done, right? So you think, I mean, you don't submit a pull request thinking that you probably need 17 extra things. Well, unless you're me. So yeah, it gets a bit complicated, and then you need to like do some clever timestamp foo. But then that just drives you to using trunk-based delivery, which is good. We all like trunk-based delivery. So time period, it's the deploy minus the change committed. Again, don't just report the most recent, because sometimes it'll be really fast and sometimes it'll be really slow. Again, what you want to do is the average lead time over the last 31 days. So all of your deploys in the last 31 days, what's the average for that? Again, you can't average an average. We may have done this more than once by accident. But also, don't include things which aren't yet deployed, because they don't have an end time. So technically, like if they're stuck, you'll be amazed how many change sets you find that are just like stuck and they've never gone anywhere. So don't include them if they're not yet deployed, because technically the lead time is infinite because you don't know where it's there. The other thing which I haven't put on the slide, but I should put on the slide, failed builds don't count. You're only counting successful builds. Failed builds will skew your data. If you count failed builds, but your builds are failing really fast, that's not bad. You want that, right? You want, if I push a change and then the unit tests run because I've forgotten to run them and they fail in the first 3 minutes, that doesn't mean my lead time is a data point of 3 minutes. It just means that my failed build took 3 minutes to fail. You're just taking successful builds. Next one, change failure rate. So this one requires two data points. It's a proportion. So it's a proportion of the change failures against the number of deploys. But interestingly and importantly, and again, this isn't in the book, it's the number of resolved failures. Because if something, you'll see, and the reason why this is important is because from mean time to recovery, you want to be able to compare change failure rate and mean time to recovery. If you don't know when something was recovered because it hasn't yet been recovered, you can't include it in that statistic. So therefore, you can't include it in this statistic, which it hurts your head, but trust me, it works out. Because if you include it, then your numbers go weird. And then you have all of these debates about things which are based on data which isn't consistent. So yeah, what you want to look at is the number of resolved failures divided by number of deploys. And so therefore, the 4KM that we report, because it worked nicely, was the proportion of failures per deploy over the last 31 days. Lessons learned, it is really hard to identify a change failure. So it turns out, and like I say, this is why it's easy to just get human beings to do it and trust them. Because it turns out we're quite trustworthy, right? If we think it's broken, it's probably broken. If it turns out that there are change failures which we're missing, then that's still another reason to improve stuff, because why did we miss this? You know, it's been broken for 6 months, but we didn't know. Okay, let's add some observability, right? So the book makes it sound like you should tie a change failure to a change set. Pete and I spent a long time trying to figure out how to do this. There is no benefit. Well, for us, there was no benefit, 10 minutes, to doing this. So we stopped trying. So stuff breaks, you want to fix it. And things are being deployed because you want to deploy them. So don't stress out trying to put stuff together. And last one is time to restore service. So it's 2 data points. It's the opening time for the ticket and the close time for the ticket. Some people say, but it fails before I open the ticket. Yes, you're trusting human beings to open the ticket as quickly as possible. It's a time period. It's the elapsed time between the failure and the restoration. And like I say, if it's a memory leak, it's the time between rebooting the service to bring it back up. Because you're trusting yourself and the rest of the folks in your team that you've also logged some ticket to fix the bug, which memory leaks, right? Ignore unresolved failures. So this is the one, if it's not resolved, we don't know, right? So maybe it's been open for 17 years. This is the one that's different. Hopefully, failures are happening not that frequently. Although, like I said, at previous client, there was like many per day because it wasn't their fault. So we took a longer period. The default period for this was 120 days because you could have like a tough time, right? And you've got loads of failures happening because a team is suddenly touching a thing which they didn't normally touch. So therefore, you might suddenly get loads of change failures and your number goes really high. Other times, nobody's touching any scary parts of the system and your change failure rate is 0. Over 120 days, you probably get a pretty stable number. So that's what you want to do. Oh, other things. Everyone always gets really excited about mean or median because I think the book uses median and I think some of the early DORA reports use mean. It turns out, after great debate, we don't care. Just pick the one that tells you the things you want to know because one will hide data and the other one won't, depending on what your data looks like. So it depends. But you want to learn because we'll get to that in a minute. So this is where it gets cool. So we've got some numbers. That's fine. Nobody cares about them. Maybe management care. What you really want to do is display them and then use them so that teams can say, right, this is not as good as it could be. How can we fix it? Which is where we get here. So display and understand that people like them. Like I said before, don't build the best dashboard in the universe. Build the dirtiest, accurate, but dirtiest, hand-created dashboard you could ever do. Because you want people to look at it and do it. So minimum viable dashboard, everything's done by human beings. You probably run Jira scripts. You probably manually cut and paste things into spreadsheets. You probably do some maths in a spreadsheet, and then you edit a wiki page. The next thing you should automate, it turns out, is the collection, because it's the data collection which will drive you insane. So you just write a script and put it as a Jenkins job that, like, I don't know, collect some stuff. But update the dashboard weekly, and then you get to the automated dashboards. So there are various things, and I need to update this slide because it changes all the time. Google has a product called 4Keys. Thoughtworks has a project called Metric. There's a million plugins for everything else. The key thing is, you can't evaluate which ones of these to use until you know where your data points are coming from. Because if your data points are coming from Circle CI, but Google's 4 keys, I don't know if this is true, but if Google's 4 keys doesn't have a plugin to collect data from Circle CI, then you'll have to write the plugin, which is fine because you can do that, or you'll have to do something else. So when we started, all of these didn't support anything that we wanted, so we made our own. So this is a real life example. So the 4 key metric is this. But what we discovered was we've got all of this data and we were using Power BI, which again, I didn't think I would say was good, but actually when you get past how on earth the Power BI documentation works, you can do cool stuff. So we started deploying things because we would discuss this with the teams. Everyone in the teams would see this once a week. And it was automatically created. It was up to date by the minute. We could look at stuff and we could see the 95th and the 99th and the overall trend and all this stuff. And by doing discussions with people like Ruben sitting here, might be like, oh, I wonder why this is happening. We don't know. We'll go and add a feature to this dashboard. So that's deployment stays. You can see all the other stuff because we kept getting asked what they were, so we put them on the dashboard. Lead time for changes. It lets you have really interesting conversations. This is when the infrastructure team thought they would save some money by turning off lots of the worker nodes that were serving builds. So there was a massive queue to do builds. So then they turned some of them back on again and the queue went away. Average lead time, 60 minutes. Change failure rate, like I say, it doesn't happen very often. You can do shadow plots and plot the number of deployments behind the stuff that's happening. You can see our change failure rate was really super low because we were really proud of things. And this is mean time to restore service, right? So this is going back 120 days. So you can see, if you took a small piece, it might skew based on where you are. So we took a longer view. But it doesn't need to be 120 days. It just worked for us. MTTR 1420. And then when we saw that, we were like, right, we need to fix observability. Stuff was breaking, we didn't know it was broken, so we put in more observability. Which is good because now we've got a number to speak to people because that's instead of a feature, we're going to put in observability. But then product management would be like, okay, cool, that feels like we should have that, so you don't have to worry about it. So now we get to the last step, own and improve. This was our front page. You could see the things are color-coded based on how good we were based on the DORA, because they say you're DORA high or elite or low or whatever. And we had this, but the reason I've got this slide is because we had this, because we built it with Power BI, but you could do this in other ways. People could come, teams, individual devs could come and change the time period. And what we don't have here is you could also select the pipelines which were part of the calculation. You could select a single pipeline for a single microservice and see what the 4 key metrics were for that pipeline over the last 365 days. Or you could select all the pipelines for all the microservices owned by my team, and you could see that. We never broke it down when we reported, because that's not fair, right? Some teams have harder stuff, so their metrics are not as good as other teams. We reported an aggregate, but we gave the teams the tools to see what their stuff was, if it was better or worse, and then they could tune the practices they wanted to adopt based on what their metrics look like, which is how we get to this self-serve dashboard. So then we have conversations, people ask questions, people say that's wrong. We got quite a lot of feature requests because they're like, we don't think the number is as bad as you say it is, and it's because Pete and I couldn't do maths. And we added more code and we did more dashboards. So, key thing, and this is really interesting because I was speaking to Pete recently. The 4 key metrics will tell you how efficiently you are building and how stable your system is. If no one cares about your system, this will not tell you that. So if you're building a system that has bad product metrics, nobody would care. You were efficiently building a system, right? What you want to do is combine it with product metrics. Interestingly, since they've released and they've gone live, OpenGI went live a few weeks ago with this, they've had to slow down because product so the lead time is the deployment frequency has gone down, but it's increased the product metrics because satisfaction of the customers has gone up because they didn't want stuff changing all the time. But they got to the point where stuff was so good that they could trade that off, which was fine. So knowing the product metrics, this is not a proxy for product metrics at all. You still need to know how, whatever your metrics are, like customer signups or amount of money transfer between A or B or things sold to customers or whatever. Those things still count, and you've got to keep the two balanced. So last thing, you've got your metrics, you're looking at them, and you're like, right, this sucks, we want to make it better, incrementally better. What can I do? You just go to this list, because there's a bunch of stuff here, and it's like, you could do them all at once, but you can pick just one, and you're like, okay, cool. Our lead time is bad. What is a practice we can attempt to experiment with, right? We can pick trunk-based delivery or test-driven development. Or if you're in banking, it's always test data management, because banks have to be very careful with test data. So therefore, it turns out that everything is fast up until the point you have to get into the shared environment, which has realistic data. And there's a queue of 3 days while the data gets set up. So right, let's invest in some time in setting up data easy so that teams can self-serve data in a secure way. All of these things. Or thin story, like small stories or whatever. Typically, Thoughtworks will come in and tell you to do these things, but then everyone can see this and they're like, okay, we can prep this practice up. So my conclusions, roll your own. I would definitely recommend experimenting with the third-party ones. They're all extensible. I'm still quite glad we wrote our one because we learned lots of stuff. And I think what my call to action would be is if you are picking up one of these, look for the things that I've gone on this journey, because what you want is a dashboard and a tool that teams can use. You don't want a thing that is a stick to hit teams with. You want a tool for teams, right? So if you want to know loads more, I somehow managed to write this down as a chapter, and it's in the book, O'Reilly.